What's up guys, Onmaths here, and today we're looking at number indices. So we've already done algebra indices, and that was slightly easier than number indices, although number indices are not difficult if you know what you're doing. So just a bit of context here, we're going to have a number and then we're going to have a power, right? And that power is going to have, well, possibly three different parts to it. It might have a negative, and it might have a fraction, and let's just call this a over b. Okay? Whenever you have a negative, it just means that you've got to find the reciprocal, which means flip it, basically. Okay? Whenever you have a number at the bottom of a fraction, okay, that will become a root. So if it's a 2, it's a square root. If it's a 3, it's a cube root. And whenever you have a number at the top, you just treat that as a normal power. Okay, if you remember those rules, all right, and we've got our base here. The base isn't as important. I don't know, I was going to call it B for base, but we'll call it C. Okay, so the base isn't really telling us anything to do. It's all about what the power is, what the index is. So let's have a look at this first one. This first one kind of has 2 out of the 3. The reason it has 2 out of the 3 is it's got that negative, so we know we need to find the reciprocal. It's got that number at the bottom, but the number at the top's 1, and so whenever you have a power of 1, it's just basically the same number, okay? So if I just draw this out a bit bigger, that is telling us to flip it, find the reciprocal, and that is telling us to do the square root. Okay, so we're going to flip it. Now, whenever you just have a number, so like 81 for instance, let's just have a look at 81. 81, if you had to write that as a fraction, okay, you would do 81 over 1. Any whole number written as a fraction will just be that number over 1. So if you have any integer, it's just that integer over 1. That's it as a fraction. They mean the same thing. So when you flip it, it becomes 1 over 81. So this will become 1 over 81, but we haven't dealt with that half yet. We have dealt with the minus, so the minus goes away. We've dealt with that. We've made it a fraction. We've flipped it, okay? But we still have that half to deal with. Now, that 2 at the bottom, as I said before, means it's going to be a square root. So that's going to be the same as 1 over square root of 81. And the square root of 81 is 9, so it's going to be 1 over 9 as our answer. Now, whenever you square root a number, technically you can have a positive or negative. So I could put a plus minus there, but in these types of questions, the positive variant is absolutely fine. Okay, next one. Well, we don't have the negative anymore, but we do have a root there, and because it's a 3, it's going to be a cube root. And we do have a power, so it's just going to be squared. Let's go write power 2, but it's just going to be squared because it's 2. Okay. So let's write out the number. Okay, so let's deal with the one at the bottom first. And I always deal with the root first, because if you square it, it becomes so big you don't know how to cube root it. Okay, so always deal with the bottom first. So with fractions, if you cube root the whole fraction, you actually just cube root the top and you cube root the bottom. So we've dealt with the denominator of 3, but we haven't dealt with the squared yet, so we should still have the squared on the outside, so we haven't dealt with that yet. The cube root of 64, so what times itself 3 times is 64? So you just need to know your cube roots. And your cube numbers, so that's going to be 4. What times itself 3 times is 125, that would be 5. And we haven't dealt with the squared yet, so that still goes there. Now similarly with the cube root, we cube root the top and cube root the bottom. With squareds or any power outside the bracket, we just do it to the top and bottom. So that's 4 squared over 5 squared, so that would be 16 over 25. And we can't cancel that down any further, so that would be our answer. Next up, we've got our OCR question. Now, question A was on surds, so I'm missing out question A and going straight to question B, and it's question 16. So let's write this out a little bit bigger so we can just show it a bit easier. So again, we have a look at the three things. That will mean we find the reciprocal, we flip it. This will be the fourth root, which is a bit interesting, and this will be cubing at the end. Okay, so there's our set of instructions. So we're going to start by flipping it, and this is the order you always do, so flip it, root it, and then power. Okay, so it becomes 1 over 16, and we don't have the negative anymore because we have flipped it to the power of 3/4. Okay, now we've got 1 over, so we're going to do it to the fourth root first, and that looks like this, the 4 on the outside, but we still haven't dealt with the cubing, so we're going to leave that on the outside. We're just going to worry about that later. So the cube root of 16, now generally speaking, if you've ever got a cube root, you are realistically only going to have, the fourth root, it's realistically either going to be a 1, a 2, and sometimes maybe a 3 or a 10. It's not going to be anything beyond that. So always check, well, 1's quite easy to spot. I would say 10's quite easy to spot. So 2 is 16 and 3 obviously is 81. So just bear in mind, they're not original. They're only really going to pick 2 or 3 besides 1 and 10. So this is going to be 2, because 2 times 2 is 4, times 2 is 8, times 2 is 16. So this is going to be 2, and we still need to cube it. So 2 cubed, 2 times 2 is 4, times 2 is 8. So it will be 1 over 8. Last up, we've got our AQA question, and this time we've got a calculation and we've got all sorts of things going on. So we just need to remember some simple rules. One of the rules we need to remember, or the first rule we need to remember, is when you've got a number inside and outside of the bracket, what you do is you multiply them. And the reason for that is 2 to the power of 9 squared, which is what that's saying, is just 2 to the power of 9 times 2 to the power of 9. Rules of indices say that if you multiply them with the same base, multiply 2 powers with the same base, just add the indices. So that becomes 18, which is the same as 9 times 2. Simple as that. So we can rewrite this question as 2 to the 14 divided by 2 to the power of 18. Now the rules of indices say that when you divide, you take away the powers, or take away the indices. Okay, so this is going to be 2 to the power of 14 take away 18, which is minus 4. Now as you might remember before, if there's a negative there, we flip it. So it becomes 1 over 2 to the power of 4. And 2 to the power of 4 is 2 times 2 times 2 times 2, which is 16. So the answer to this is 1 over 16. So as long as you remember the simple rules which we've talked about in the previous questions, dead easy question really, dead easy. And for question 24, this is really nice because this is the part of the exam where you're getting a bit fatigued and the questions are getting really, really difficult. And to have a question like this, just to calm things down and get you back on track, is a nice one. Similar thing with this one, we've already covered it. That's going to be the square root, and then this is going to be the cube at the end. So we're going to square root it and then cube it. Okay, so square root the 25, and I'm just going to show that 3 is still on the outside. Square root of 25 is 5, and then 5 cubed, 5 times 5 times 5, 125. And again, when you square root something, you get a positive and a negative answer. So you could have written positive or negative 125, or even plus minus 125. But for these types of questions, they always seem to give you the marks for the positive variant. Well, I hope you found that video useful. If you did, then please click the like button. It really helps us out. If you want to see more from us, we release videos every single weekday, Monday to Friday, at 9 o'clock in the morning. And if you want to see even more from us, you can check out our website onmaths.com, which is packed full of wonderful free resources to help you with your maths. Keep the comments coming in because summer school will finish and we're looking for ideas of videos you guys want us to make. So just write them in the comments below. And if you want to check out Onmaths' website, there will be a magic card that appears above this video now. Otherwise, thank you very much and I'll see you tomorrow.